I hope I'm comprehensible and also online. I hope I get through to everybody. Good afternoon. The first YuniKorn meetup in person. We've done a couple of online meetups over the last year and a half, 2 years. But in this case, the first one online. So we've got a couple of things lined up. Riani is going to show us what they're doing with YuniKorn at Pinterest. After that, I'll give a little bit of feedback on what we've seen happening around YuniKorn and scheduling at ApacheCON. And then the third bit that we'll do after that is we'll, together with Craig, go over a bit of the roadmap going forward that we've planned from a Cloudera perspective, and also a number of things that we've already pushed out in and towards the community. So we had planned to have Wei talk about Carpenter. Unfortunately, that didn't go through. We'll plan that for the next time. We'll make a meetup, and we'll see what we can do at, in the next months ahead for us. So pretty happy that Rani was able to step in pretty quickly on the spot that was left over. So Rani, I'm gonna give the floor to you. If there's any questions and things like that, even for the people that are online, raise a hand. We can pull you in. We can unmute you and let you talk. I'm not sure if you want to set up or answer questions while you're doing the presentation. So let us know what your plan is for that.
Sure.
So, Riani, welcome, and over to you.
Sure. Hi, everyone. I'm Rainy. I'm a software engineer from Pinterest. I'm currently working at Pinterest Big Data Platform team. Here's today's agenda. I will first introduce Pinterest and our current big data platform. Then I will talk about how we use Yarn on Hadoop as resource management. After that, I will go through how we use YuniKorn during Kubernetes evaluation project. At the end, I will go through some future work and the Q&A session. So Pinterest is a social media, web, and mobile application company. Our mission is to bring everyone's inspiration to create a life they love. By the end of 2021, we have around 430 million active users, which is a 30% increase from the end of 2019, when we had 300 million active users. We grew a lot during the pandemic. Next, I will give some high-level overview about current big data platform team at Pinterest. It includes 4 layers. First layer is workflow layer. We adopted Airflow and built an in-house service called Spinner to run workflows. The second layer is service layer, which includes job submission service. It will handle all the submission and launch the job and track job information on Hadoop cluster. It also includes fine-grained access control to handle the security, authentication, authorization part. We also integrate with Pinterest monitoring system. We use dashboard. Besides these, we build a tool called Dr. Elephant to run job analysis, providing debugging advice to users. The last service we had in this layer is chargeback, which can calculate the cost for applications. The next layer is compute engines. We use Spark and Spark SQL, also MapReduce, Presto. Recently, we added Flink for streaming platform. The bottom layer is infrastructure. We build on top of HDFS, Yarn, and S3. Next, I will talk about how we currently using Yarn on Hadoop. We have 3 core features. First one is tier-based workflow and allocate resource. So we work with all the customers to define tiers for their applications. and allocate resource based on these tiers. The second feature is we create hierarchy queue structure from organization and project and tiers. There's an example on the right side, which you can see a root node represents the entire resources on the cluster. Under the root node, we have a leaf node, which represent different organizations. For example, data engineering is one of the organizations at Pinterest. Then within the leaf node of this data engineering, we allocate resource based on different projects, including core services, data warehouse. And for example, the project has child nodes. We can define different tiers. Like a data warehouse has tier 1 and tier 2 applications. So that's a current structure. The third feature is we provide cross-cluster routing to move workloads around. From the diagram at the bottom, you can see tier 1 application always has more resources than tier 2 and tier 3, since they have higher priority and they are the most critical application on our platform. If tier 1 application no longer need so many resources, tier 2 and tier 3 application can use those resources. With these three core features, we can set cluster size static by taking advantage of reserved instance price from AWS. We can also provide queue level resource isolation and provide enough resource for tier 1 application. And so from the beginning of this year, we are thinking to find an alternative for next generation of big data platform. So we started working on Spark on Kubernetes evaluation. Next, I will talk about how we use YuniKorn in this Kubernetes evaluation project. We ran workload stress testing on Kubernetes cluster. There are two main motivations. First one is to evaluate how different component of Kubernetes platform can perform under heavy load, including control plane, API server, and the scheduler. The second motivation, we want to evaluate scheduler performance for both YuniKorn and default scheduler. We choose YuniKorn because it provides queue-based scheduling, which is a critical feature we are actively using in Yang, like I mentioned before. And the goal of this workload test on Kubernetes cluster is to reach 100% success rate with similar load as current production ad hoc cluster, which is near 24,000 maximum concurrent running pods. We separate this workload stress test into 5 stages. On stage 1, we launched a cluster with 85 nodes and we installed YuniKorn scheduler. We want to run multiple Spark jobs on this cluster. The test completed with 100 and 300 Spark jobs, but the test failed when we launched 1,000 Spark jobs. We saw almost half of the job stacks, and the YuniKorn scheduler crashed due to out of memory issue. After increasing YuniKorn scheduler container memory from 500 megabytes to 2 gigabytes, we were able to successfully run 1,000 Spark jobs. So from this diagram, we can see the number of maximum running pods has reached to 4,000. On stage 2, we doubled the cluster size to 170 nodes. And our goal is to reach 8,000 concurrent running pods. We also launched 1,000 Spark jobs. Test failed initially. We found YuniKorn couldn't allocate more than 2,400 pods in total. And the EC2 instance CPU utilization was much lower than usual. We started the investigation. First, we removed the YuniKorn. With default scheduler, we were able to reach 8,000 concurrent running pods. which proves YuniKorn was the bottleneck. Then we check some information from YuniKorn logs. We enable the debugging log in YuniKorn. We found that it's caused by promises pause setting on each Spark job, which slow down the YuniKorn node selection process. After removing the promises pause setting from Spark jobs, we were able to reach 8,000 concurrent running pods with YuniKorn scheduler. In this stage, we also compare the performance between YuniKorn and default scheduler. We found YuniKorn has two advantages. First one is it can better utilize the cluster resource. With same test, YuniKorn scheduler can complete within 94 minutes, while a default scheduler needs 150 minutes. The reason is, I think jobs can start running without waiting for all the resources to be ready with YuniKorn. We set Spark executor configuration to 80%. So from this diagram, we can see with default scheduler, jobs basically running in batches since they have to wait for all the resources to be ready, then start running. But with YuniKorn, the graph is much flatter since jobs, they don't need to wait for all the resources. The second advantage of YuniKorn is it can support maximum running application on each queue, which is a critical feature we are using on Yarn. Because if there's a lot of jobs running, they could end up competing for resources, and a certain amount of resource will be wasted. This could lead to job failure. So we started working on this ticket and ready to contribute back to the community. On stage 3, we increased the cluster size to 500 nodes, and the goal was to reach 24,000 concurrent running pods. Test failed initially with 1,000 Spark jobs because they cannot fully utilize cluster resource. And the maximum running pods was only around 10,000. We follow the same investigation steps as before. First, to remove the YuniKorn. With default scheduler, we saw the same issue, which proves YuniKorn was a bottleneck. YuniKorn was not a bottleneck. And then we keep debugging. We found some information from Spark operator showing jobs was in pending state. We suspect it related to Spark operator scalability issue. Then we scaling up to 5 Spark operators. Then YuniKorn scheduler was able to fully utilize the cluster resource. So this graph shows the result of our largest load test. It's a similar scale to our current production ad hoc cluster. YuniKorn was able to evenly allocate the resource between 5 queues with 5 Spark operators with same weight relatively well. So we basically submit 200 Spark jobs to each YuniKorn queue by each operator. The overall job success rate was around 98%. I will talk about more how we improve this number in following stages. Since this stage was our largest load test stage, we found several cluster-related issues. First one is EKS control plane failed due to running out of IP. We ended up creating larger subnet to support this large scale. The second issue is we saw IP allocation delay. We ended up pre-allocating 90 IPs to each node and updated the VPC CNI setting for minimum IP target to 90 and the maximum ENI to 3. The third learning is we hit CNI API limit on EC2 instance. We worked with AWS team to increase EC2 API limit for CNI. Next learning is in order to increase core DNS number, we use the kube DNS autoscaler. Otherwise, jobs will fail due to unknown host exception. The last learning is we had to increase root volume from 10 gigabytes to 100 gigabytes. Otherwise, pods will get evicted during large-scale load test. So on stage 4 and 5, we focused on improving the success rate. To save some cost, we scaled down the cluster size back to 85 nodes and launched 1,000 Spark jobs. We checked the logs to see why those jobs failed. Seems like the webhook setting in Spark operator caused performance degradation. We saw a pod shows out of CPU error, and the jobs failed due to this error. So we disabled the webhook in Spark operator. Then we were able to reach 100 success rate with default scheduler. But with YuniKorn, we were not able to reach 100%, even disabling the webhook. On stage 5, we focused on to reach the same goal with YuniKorn. We first tried the YuniKorn GAN scheduler. We were able to reach 100 success rate, but the overall test duration was much longer than usual. It took an additional hour, I think. Then we started investigating and implement the max application feature, which can prevent resource compete. And with that feature, we are able to reach the same goal with YuniKorn. So this graph shows our test results with max application and YuniKorn scheduler. We used 5 YuniKorn queue. Each queue, we set maximum running application number to 12, and we launched 200 Spark jobs to each queue. So the overall test performance, duration, CPU utilization all look good. Let me summarize the journey of our workload stress test with YuniKorn. So on stage 1, we increased the YuniKorn container memory to support 1,000 jobs on 85 nodes cluster. On stage 2, we removed the promises setting to improve YuniKorn performance. On stage 3, which is our largest load test stage, we scaled up operator to 5 operators and found several cluster-related issues, including needs larger subnet, customized VPC CNI with pre-allocated IP to address IP allocation delay issue. We also increased the EC2 instance API limit for CNI. We also increased core DNS number and the root volume on stage 3. On stage 4, we disabled webhook in Spark operator to reach 100% job success rate with default scheduler. On stage 5, we implemented a max application feature so that we can reach same goal with YuniKorn. Next, we are working on designing job submission service for Kubernetes. We are also working on productionized ad hoc cluster. Besides these, we are evaluating Graviton for cost efficiency. So we are looking forward to collaborate more with the community and contribute back to Spark on Kubernetes ecosystem. That's all. Any questions?
Any questions from people in the room here?
One question I have is that in your introduction in Yarn cluster, you have a tier concept. So is that the same as a priority?
Yes, tier 1 has higher priority with a heavier weight. We use a weight setting in Yarn. So tier 1 application always has a larger weight than tier 2 and 3. So it's higher priority than tier 2 and 3.
Okay. I'm asking because I think that is very relevant to what we wanted to do to implement priorities in YuniKorn. Right now, we don't have that, but I think that would be pretty relevant.
Mhm. Yeah, it will be useful since we basically want the same feature in Yarn as in YuniKorn on Kubernetes later.
Makes sense. And a very good, I think, very good presentation that basically shows that the parts from zero to, to get on to production, really informative. Thanks a lot.
Sure. No worry.
I've got a question on this one too. The version of YuniKorn that you were running, especially around where you turned on gang scheduling with the gang delays, which version was that? Was that 1.0 or was that before 1.0 or?
It's 1.0.
1.0 version. Okay. Because we've since 1.0 found, I think, 2 bugs around delays with gang scheduling.
Okay.
That would explain that big delay.
Slow.
So that might help. I think they're coming in 1.1. Or they came in 1.1, or maybe they're only coming in 1.2.
Okay.
So that might be a thing. So that's the Prometheus board. Could you explain a little bit more about that? Because it's been mentioned earlier, but I'm still not quite clear what that really means.
Sure. That's we use an exporter on Spark job YAML file, and Prometheus will get metrics data from this port. Somehow, I think this setting slows down YuniKorn node selection process. After removing this port setting on Spark job, I think YuniKorn was able to work more efficient based on our observation. It's related to the YuniKorn node selection algorithm.
I don't have a direct answer to that one. We need to look into that.
Seems YuniKorn use, I checked a Jira ticket. I think the background is the YuniKorn node selection will scan all the available port on node. But if one port is already occupied for Prometheus, it will somehow slows down the process.
It could be IP address related selection. That could well be it. Yeah, would be nice if you could log an upstream Jira for that, so that we can can have a look at that later on, because that will impact probably other people too. And I think the Spark operator scalability. I don't know if that was your team, Wei, that mentioned that at the ApacheCON, or it was the other team out of the company. But you've seen similar things?
Same. Yeah. Basically, I think people are using multiple Spark operators to mitigate the performance issue, scalability issue. Yeah, I mean, Spark operator is not a must-to-have component in this picture, and some people that doesn't use Spark operator at all. But if Spark operator is used in certain scale, we use 5 or 6 instances per cluster, so that is no issue. Yeah.
Okay. Good to know.
Might be something that we need to document.
Right.
So it might be something that we need to document as part of the performance issues that we see. Yeah.
Those are very valuable. We should document.
Yes. Yeah, it looks like the number of these we've seen before. Some of them we haven't seen before. We know from other people that have run big clusters that they've said, yeah, as soon as you go and have 500 or 1,000 nodes, then you run into the API server problems. So yes, we should be documenting that. Bill, any questions online for people? Bill?
Testing. Okay. So we have a question online. It's from Paul, and he says, can you explain further in detail why YuniKorn lends itself so well to batch job resource management versus other types of job resource management?
Are you referring to default scheduler resource management?
I'm assuming that he heard that, and he's going to give me a follow-up here. I don't know.
Okay, I think
You might have to determine what you think he means. Oh, he says yes. Default
Yeah.
K8 versus default K8S, I think is what he says. Yeah.
Sure. We did compare the performance between YuniKorn and default Kubernetes scheduler on stage 2. So YuniKorn has two major advantages. First one, it can better utilize cluster resource. Basically, the test completed faster with YuniKorn. The reason is jobs no longer need to wait for all the resources to be ready with YuniKorn. However, with default scheduler, they have to wait for all the resources to be ready. Then they ended up running jobs in batches. But with YuniKorn, we can see the graph is much flatter because jobs can run with 80% of resource available. The second advantage is for our team is that we are heavily using this max running application on Yarn. This feature is not supported by default scheduler. And this feature can help us avoid a resource compete and improve the job success rate. These are the two reasons we prefer YuniKorn.
Thank you. Thank you. Those are all the questions online.
Okay. Great. Thank you, Liani, for this presentation. I think this gave us a good overview, and I think it lines up with a number of the other stories that we've heard from YuniKorn deployments compared to the default scheduler and going forward. If there's anybody that would like some refreshments, there's refreshments on the side here. We've got pizza later on for that. Thank you for that. And we'll go the next step. That means that it's me that needs to go and present. Okay, there we are. Okay, so for people who are not aware or who are aware, we've had the ApacheCON about a week and a half ago, 2 weeks ago in New Orleans. And at ApacheCON, we had a number of two presentations around YuniKorn, and there was a cloud native track also in which people were talking about scheduling, batch performance, batch things on Kubernetes, not just using Yarn, but big data and other batch loads working on a Kubernetes kind of a setup. It's not going up. So we had two specific presentations on YuniKorn. The first one was a presentation from Apple by Charon and Bowen. Charon is a PMC member. Bowen is a contributor, I think, at the moment. They went through what they use for Spark and YuniKorn in their environment. It's a use case scenario that looks similar to what was just described by Pinterest. pushing Spark jobs that were previously running on Yarn onto a Kubernetes environment in a auto-scaled cluster in the cloud. So primarily looking at elastic Kubernetes, start small, grow, have the cluster auto-scaler running, submit jobs, get everything working as easily as possible. They're running production workloads. They came back with a number of their findings, and a number of the findings lined up exactly with what Pinterest said. Yes, we are seeing better performance. We're seeing better usage of the resources, really the same things, but also the same problems around IP addresses, scaling of Kubernetes itself. So really confirmation that it's not just YuniKorn, but it's really the underlying infrastructure on Kubernetes itself that you need to have a good look at. It's not just put YuniKorn in and, oh, let's see, all our problems are going away. That's not the case. So there's no presentation sheets up there yet for that presentation. So ApacheCON has requested them. They weren't there yet, so I couldn't link to the presentation just yet. Hopefully they'll come. Now, I haven't reached out to Sharon yet to see if he will do that for us. I myself had a presentation also in the same track around YuniKorn and the direction that we're going. So we talked about the architecture that we have. We've got two architectures within YuniKorn, as you probably know. The default architecture, which we started off with, what was it, 3 years ago, Wei? Probably around 3 years ago. And we've got the plugin architecture, which we started probably a year and a half ago, approximately, after a number of false starts with that. We've pushed that up as a technical preview in 1.0. When we did that, we found a number of problems there. So we went back to the Kubernetes community, and we've noticed that they had similar problem with whatever scheduling things they were doing, with Volcano, with all the plugins that they were doing. So we came to the conclusion that we need something that will help us get the plugin to the same level as that we have with the default scheduler. That created CAP 3521, which is currently being scheduled for implementation in Kubernetes 1.26. So we work with the Kubernetes community, and we're trying to get that going. So talked about a number of these things and about the problems that we've seen and all the whole process that we have to go through. Because the Kubernetes community, the CNCF, is different than an Apache community. It's a different kettle of fish. Apache is open. Pinterest came up with a patch and they said, oh, we want to contribute this. So we're working on getting that. In the Kubernetes community, it's the other way around. You need to come up with a CAP. You need to get sponsors for the CAP. You need to write the whole heap, and then you get implemented in different phases and all that kind of, so it's different. So we talked about a lot of that. I also talked about the user retrieval and the quotas that we're currently working on, which are planned for the next release, which a number of people have asked for. Can we get user quotas? Can we do a little bit more? Again, at a Kubernetes level, we have run into some limitations of Kubernetes. Kubernetes doesn't know a user. It's got a service account. So how do we get that real user that submits that job into our system so that we can charge him for what he's doing? So that's what we're looking at. We've put the designs up. They're all available upstream as part of the JIRAs and the presentation. So talked about that. A lot of good feedback on that one. Then we looked at further things in the roadmap that we were looking at. Preemption, priorities, a number of other things. Link to the presentation is up at the Apache website that gives you all things. Link is in here. We'll get that also out on the YuniKorn website. Then there were three other presentations. One was in a different track that was more on the Spark and data processing side from a different team within Apple. Also Spark focused, Elastic Kubernetes. Completely different team than we had with Choran and Bowen, which were using YuniKorn. That seemed to be far more focused around resource monitoring, low workloads and production workloads, scaling, auto-scaling, changing things around there. So, and they were based, as far as I could tell, they didn't want to say yes or no to the question, but it looks like they're using Volcano. So the direct question was like, are you using YuniKorn or are you using a different scheduler? And they said, we can't say. So that's known. We can live with that. But based on what they mentioned during the presentation, I could infer that it was Volcano. Oh, sorry. Then a presentation from Informatica. Informatica was a bit out of left field, how they came into this whole thing. And their focus was on heterogeneous workloads and cluster hardware. So Spark jobs, other flow jobs, but also GPUs, ARM, Intel processors, everything mixed together, long-running streaming jobs with short-term, tiny data processing jobs, everything in one cluster, and then try to get everything working as well as possible with the minimum amount of interaction from the end user. So they did some custom Kubernetes scheduling stuff to make sure that they had all the things that they needed. They worked a little bit around gangs and things like that, fairly limited implementation that they did. The focus for them was on predicting job resource usage. So they built all of this into their Informatica setup that they've got, in which they generate the Spark jobs, in which they generate the whole thing. So they know exactly what's going on in the job. So what they then do is they pull all the statistics out of the job and say, oh, if you do a join or if you process large files, then you want this amount of memory, but you don't go above 16 gigabyte of memory because you never use more than 16 gigabytes. So we create the pods with only 16 gigabyte of memory. Oh, you are processing small amounts of data, then you don't get a GPU. You only get a GPU if your data sets are larger, because GPUs work well for large data sets, but they slow things down for small data sets. So they would put that on the jobs automatically without interference from the end customer. So they change the way that the jobs run, and that's how they push their clusters to high performance, everything quick, everything going through. So there's a link to their presentation. There's a lot of details in the presentation. I can show something for people that want to have a look at it a little bit later. But it was purely focused on doing all the work beforehand and less on what they do at the real end layer of the scheduling. But yes, they ran ARM, GPU, and Intel-based all in one big Kubernetes cluster. So, and that's a little bit of a different approach. I hadn't seen that before. Most people say we run Intel-based or we run ARM-based, and GPUs don't come into play a lot, except for the ML jobs and things like that. So that was a completely different one. The third presentation that came up was like, okay, this is really weird. People still running Mesos, and they use K3 clusters, K3S clusters, so a bit like Kind, really lightweight Kubernetes clusters. They spin them up inside of Mesos. And they do that for different workloads, and they say, oh, we've got a workload that needs to run on Kubernetes. Let's spin up a small Kubernetes cluster, drop the workload in, and then when things are done, they kill the Kubernetes cluster and everything is gone, and they reuse the nodes, and they keep on doing that. And they build a whole infrastructure around that, submitting things. And they said that worked really well for them. They got high throughput, high usage of their nodes, all of that. Again, that presentation has not been uploaded yet for the presentation sheets. I would really love to see that one again and walk through there was a lot of detail in there. But yeah, they spun up, instead of what most people would do, you spin up a Kubernetes cluster and you run your workload in there. They would spin up tiny little clusters and throw them out every single time after they've done things. So, was the only presentation at ApacheCON that still probably mentioned Mesos. I don't think anybody else mentioned Mesos anywhere. It was either Kubernetes or Yarn as the two resource managers, and that was it. So that was really all that was there. So key takeaways from the presentation that I did around YuniKorn at ApacheCON. User and group quotas, highly anticipated. Lots of people said, we want this, get this to us. So that was really good to hear. So we found something that not just Cloudera wants to use, but the community wants to use. So that's good to hear. The user retrieval part, which we designed. So when we looked at the whole user things and the user quotas things, we said, okay, we're missing information because a service account is not good enough for us to hook things into, because if I submit something and my neighbor submits something, we could be using the same service account, but that's not good enough for accounting our quotas against. But we found that in an admission controller, we do know exactly who submitted it. So we get the end user details. It either comes out of the certificate, or if you do some specific LDAP authentication or whatever you do at the Kubernetes layer, you do know the end user. You get the real username and you get the groups that the user belongs to. If that could be LDAP groups, that could be other things, but you get all that information in the admission controller. So what we did is, for our implementation around the user retrieval, we pull that information out through the admission controller and we put it on the pod with some security things around it to make sure that not everybody just can fake the user information in there. So a lot of questions were raised about that. People hadn't thought about doing that, and it does fill that gap that we saw, and it took us a good while to figure out that was how we would get the user information out. So that will help us. And the people from Informatica, other people, all of them asked, okay, so how do you do that really? And like, the design is up on the YuniKorn website and we are implementing it at the moment. So the first pull requests are up. So go and have a look. That's how we do it. And so we'll probably see other people pulling that same detail out going forward. The other question that was asked and that people were interested in was preemption support. So we used to have preemption code in YuniKorn. we removed that in a pull request not too long ago. It never worked. We never tested it. It was written three years ago. And we put it in and was like, okay, this is something that we really want, but like, we don't have time to do any of this. So we've got way more things to do. And it just sat there and it just got older and older and older. And all of a sudden it just wouldn't fit anymore. So we said, okay, let's remove it. Let's start from scratch. Let's implement it from scratch again. So people said, it is important. We really need this. We really want this. So yeah, everybody wants it. We're working on the design at the moment. It is another week and a half. Probably 2 weeks, then we'll have the first draft of that one up for commenting, and we're hoping on feedback and things like that. Because again, when we look at what Kubernetes does, Kubernetes just says, look at all the pods. Oh, which one is the highest priority? Okay, that one needs to be scheduled first. And if it doesn't fit, let's kill some of the low priority pods. That's all it does. It doesn't look at queues, it doesn't look at quotas, it doesn't look at anything. It just says high priority low priority can be killed, high priority needs to be scheduled. By the way, that Spark driver, if I kill that Spark driver, it also kills 200 other pods. The default scheduler said, I don't care, just kill, and I need that spot because that's a low priority. And so having the knowledge and at least the idea about do not kill my driver, that's important. So that's going to be baked into the preemption support that we want to do. So that's coming. Federation, more from a point of view of distributed quota management. So what we've seen with a number of clusters and a number of Kubernetes environments is they don't scale up. 1,000, 1,500 nodes. If you get to 5,000 nodes, you're really at the end of your Kubernetes kind of clusters. But you need to do a lot of work to get to that kind of a size of a cluster. So people start running smaller clusters, 800, 1,000, 1,500 nodes, and then create multiple of them. But in that case, if you get a submission kind of system, which in all the Apple talks and even for you guys, you say, we submit to different clusters. If I submit to one cluster and I submit the next job to a different cluster, how does that work with quotas? You still want to limit me to only run a certain amount of jobs or a certain amount of resources over all these clusters. Because otherwise I could just try to fake it till I make it and get things running over as many clusters so I can run whatever I want without breaking my quota. So from a distributed quota management perspective, we want to have multiple clusters, but still aggregate that quota up into one system and say, no, your user quota, you've used 100 gig here, 100 gig there, and your quota is 200 gig, you can't schedule anymore. So that is the federation kind of thing that we're looking at. Not as much from a submission point of view. People have worked on submission gateways. I think Apple has got 2 different ones, at least, that I know of. Livey is there, Spark operators, things like that. So there's multiple things like that that are around. So it's not from a submission perspective, it's more from a quota management perspective that we're looking at this. So that were the key takeaways that I got from the Apache Con talks. So I think looking at our roadmap and looking at what we talked about earlier, I think we're fitting in nicely with all the questions that came back at that level. So I don't think we need to do anything else, but if there's other things that we need to do, we would love to hear all of that, because maximum application management that was shifted all the way to the side. Nobody was really looking at it up until Pinterest said, hey, I want this. Hey, go ahead, give it to us. So if there's anything else that people come up with, please let us know. Okay. Any further questions on this?
What is the release time frame you're looking at?
It should be on, so that people online can hear you too.
Okay. So for the plugin mode, what is the release ETA you're looking at?
Okay. Let's answer that as part of the roadmap, because that's a complex answer that I can't just give you 1.2 or 1.3. There's a couple of things that we're looking at, but that's a complex answer. So we'll talk about that as part of the roadmap, because yes, it's not going to be that easy. We're trying to do it as quick as possible, but it's a bit more complex. So we've got a sheet specifically on that as part of the roadmap presentation that will follow after this. Yeah.
Okay, so for the last one you mentioned in the previous slide about the distributed quotas.
Yeah.
Does that mean there's going to be a service on top of YuniKorn that's going to run outside of YuniKorn? Like, is that going to be a wrapper out of YuniKorn because it has to manage multiple clusters?
Yeah, correct.
So you're going to, okay.
Correct. So we're looking at exposing for every YuniKorn scheduler all the quota information, the usage information that it has internally, and then make that available to some kind of aggregation service. Say, here's everything that we've got, and then we can pass that information back. Again, that has only just popped up out of the ApacheCON kind of presentation. So we haven't got the design yet. We probably only talked about that for an hour or so earlier this week, but that's it. So we haven't got a proper design. We are not anywhere near getting that out there. I know that people want it. There were so many questions that popped up during the ApacheCON presentation. It was like, oh, can we do this over the clusters? It's like, no. But we want it over the clusters. Yes, I can understand that, but no, not now. Please wait. Help us out.
So which one of those features is in your roadmap right now? Like
1, 2, and 3.
Okay.
Only the last one isn't.
Okay.
But if you've got ideas for design and we're willing to contribute them, we're definitely interested in that.
Yeah, sure.
I think the takeaway from the distributed quota management is there's enough buzz that we've seen from community members in ApacheCON that it's definitely something we need to investigate and put some effort towards. There's definitely demand out there.
So there's, I think Sunil doesn't want to talk. He just want to say that there's pizza in the back. So we'll take a short break. Let the people get some pizzas, and then we'll go and Craig and I will talk a little bit about the roadmap and the things that we are working on, show a little bit more about the design of preemption and stuff like that too. So be back in 5 minutes. Me? Okay, we're gonna go and start the last presentation for today. So if you would like to take a seat, please. Okay, so last presentation for today. Craig and I will talk about some of the roadmap things that we've been working on and what we what we think is going to come in the next releases. Roadmap, always with all the caveats possible. It might happen, it might not happen. We might divert from the road. Who knows where we end up? But this is what we think we're going to do in the next period. YuniKorn 1.1 came out about 6 weeks ago, I think, now. 1.2 is the next release that we are looking at for this point. So during the ApacheCON presentation, this was also the approximate roadmap that I gave at that point in time. So we're looking at application limits. That's the max applications, max running applications from Pinterest that's going to come up. So I need to just do the reviews if I get time, and we'll get that in. User and group quotas, which is being implemented at this point in time by some of the people working from Cloudera. And the enforcement design, I still need to publish that because I haven't been able to get some time to do that. It is just sitting in my outbox, just waiting there to go out. So hopefully, if KubeCon is not too busy next week, I'll do that while I'm there. Then things that have popped up over the last weeks that we need to look at. So application limit use and group quotas, that is the focus. We need to get that. We want to get that out for 1.2. That's the minimum. The other thing that we're looking at is the ever-evolving Kubernetes releases and the Kubernetes versions that we need to support and we need to move to. So Kubernetes build upgrade from 1.20 to 1.23. So we currently have the internal dependencies in the Go mod file are 1.20. That gives us a limited range of supportability against Kubernetes. Officially, a scheduler is only allowed to work against the next minor release. So a scheduler from 1.24 can work against an API server from 1.25. It is not supposed to work against a scheduler from 1.20 or an API server from 1.26. And a 1.24 scheduler can't work against 1.23. With YuniKorn, we've always been really bullish and we've always been able to get that stretched slightly. Currently, we support
officially 1.20 and up, but it's known to work on 1.19.
So 1.19 up until 1.24, not 1.25.
25 is fixed just post 1.1.
Not in 1.1. We're going to try to move to 1.23 for our internal build. We'll talk a bit more about that later.
I don't actually have a slide for that, so we can probably cover that right now. So one of the, Wilfred talked about, we played a little bit fast and loose with some of the versioning, and we can get away with that because the reality is we don't need we don't care about every object that the API server exports. For the most part, it's things that the plugins need for predicate evaluation. And for us internally, it's mostly nodes, pods, and that's about it. And those things are relatively stable. That said, there are things especially when the version we build against really defines which plugins and predicates we support on any particular version. So for example, big motivation for this upgrade is we've got, in the time since 1.20, CSI storage capacity is a plugin that is available. That didn't even exist in 1.20, or it might have been in an alpha phase. But you can run YuniKorn on a newer Kubernetes release, but that functionality won't be part of the plugins that are loaded at runtime because it didn't exist in the build. So 1.23 gets us up to where we at least support some variant of that. So that's kind of a nice thing. We've seen a couple other kind of weird issues people have run into when using some optional features of newer Kubernetes releases that seem to be resolved when we do this. This does mean we're going to have to drop support finally for 1.20 and below because one of the things that happens on startup with the scheduler is a bunch of informers get registered for objects on the API server. The versions of the objects that are requested are the latest available ones based on the version we build against. So that means these will be the 1.23 API versions. Unfortunately, there's a few of those that didn't exist in 1.21 and below. And so you'll end up with a scheduler that just starts and never completes starting and never schedules anything. So it's kind of broken. So the good news is, we've looked at all the cloud vendors based on when we are planning to release this. There shouldn't be anybody really running 1.21 in any serious capacity in the next few months, probably. All the major cloud vendors have either dropped support already or are about to.
And then for the major cloud vendors, we're talking about Azure, AWS, and Google. But even what we also looked at is the OpenShift container platform. Because if you pick those four, OpenShift is probably something that people run in their own data center. So that could be important, but we've looked at all of those and they either are dropping 1.20 this month, next month, or they've already dropped it. Even out of extended support, you can't create any new clusters anymore. So we should be fine if 1.2 is going to be released by December or something like that. You can't create a 1.20 cluster anymore in the cloud vendors. So we should be good. The other thing that we're working on, which we don't know exactly when it's going to land, is priority support within the system. So we have done some priority work already to be able to support daemon sets in the right way and do preemption for daemon sets and all that kind of stuff. So some stuff is there, but it's not completely in the scheduling cycle. Priority support is what is going to give us priority inside of the scheduling cycle. So if you have a pod with a certain priority within an application, it will be scheduled before a pod with a lower priority within the application. That kind of support, that's what priority support is going to look at. That's going to be added. And what was the last point on the slide? Preemption. Okay. Preemption. The elephant in the room. It's a big one. We've removed the code, but we need something new because everybody wants it. Everybody needs it. It's needed around the quotas. It is needed for other things that we want to do. So we really need to get something on preemption going. So over the last couple of days, we've been brainstorming for a while now and talked to different people. At ApacheCON, I've talked to people. We looked at what Kubernetes does for preemption. It's completely broken, so let's not talk about that any further.
We'll talk about it a little bit and how we improve on it. But yeah.
And yes, let's talk a little bit about it and see what we think we need for preemption based on what we know that Kubernetes does wrong. So that's what we hopefully will get up and going in the next weeks in design. Okay, priority support. I'll let you take this one.
Sure. So a key design constraint that we're really trying to go with for both preemption and priority is we want to be compatible with Kubernetes where needed and reduce the cognitive load for users who want to use YuniKorn. So wherever possible, we want to do things how Kubernetes does it, unless, as we're going to show, Kubernetes does things that are kind of broken. And then we want to either support that or at least give you a nice out to do things better. So priority is interesting, as Wilfred has already mentioned earlier. When it comes to preemption, we talk about priority before preemption because in Kubernetes, especially, the two concepts are completely tied at the hip. You cannot separate them. Priority classes are named entities in Kubernetes which have a priority value, but they also specify a preemption policy. Unfortunately, Kubernetes' preemption policies are either never preempt anything else or preempt anything with a lower priority. Conspicuously missing from this and very, very important for the sort of workloads that a lot of people want to use YuniKorn for, is the ability, there is absolutely no way in YuniKorn to mark a pod as, please do not preempt me. And that's definitely needed.
One little update, it's not within YuniKorn, within Kubernetes. You can't tell Kubernetes to not preempt a pod that is already running. So you can tell Kubernetes to not preempt other pods while scheduling, or do not preempt other pods while scheduling. But after the pod has been scheduled and it's running, you can't tell Kubernetes to not preempt the pod. The only thing that it then takes into account is how high is your priority. That's the only thing that it looks at. And if it's a low priority, anything goes. So that's not something that we want, because it might be a low priority pod that is still really expensive. If you've run a driver pod on a low priority for days on end, and you're 99% done with your processing, and you kill the driver pod, then you've lost all your work, and all those other pods, all those executors, everything has been going for all those days. Really expensive. You don't want to come back to your boss and say, oh yeah, Kubernetes preempted my driver pod. I've spent $50,000 worth of cloud credits and I've got nothing to show for it. You can't do that. At least we think you can't do that. Kubernetes doesn't think that. We think you can't do that.
So, but even priority, which is certainly the simpler of the two features, there's multiple ways to tackle this. Some environments want priorities to be global. This is kind of how Kubernetes only has a single queue. And so priorities are effectively global in Kubernetes, meaning if you have a high level or high priority system pod, which Kubernetes priorities literally can be any 64-bit integer, or 32-bit integer. So you can literally have a pod with a priority of 2 billion, which I think that's where all the system pods start. There's probably a good reason why those ought to be able to jump in line ahead of anything else on your cluster. On the other hand, if you're running a multi-tenant environment where you've got multiple departments, let's say, you might have quotas set up where you don't really want department A to preempt department B or vice versa. And so there isn't really a one size fits all approach in terms of should priorities be local or global. So what we've come up with this idea of a fence, where essentially you can take a portion of the queue hierarchy. So maybe it's a whole department, maybe it's an individual queue, and fence it off, which basically says we're only going to consider priorities within that subtree and not outside of it. Now, this is a unidirectional operation. So at the parent level above that fence, basically everything from outside of that fence will appear to be the same priority, so it can still be balanced against other workloads. Additionally, you can offset an individual queue. So for example, if you can combine these two things in really powerful ways, and they don't have to go at the same level of the hierarchy, but you can essentially say, in a particular subqueue, everything that's within this, I'm going to treat as though it has a +2 priority. I'm going to offset it by 2. So if I fence everything within that, I will get individual priority-based scheduling within that queue, but from the perspective outside of that queue, everything will appear to be a priority of 2, or whatever you set the offset to. And so that's how it'll be balanced against things further up the tree. This lets you do really powerful things where you can essentially say, all of my stuff that's running a kube system gets its own system queue. We're not going to fence that queue at all, which means if it uses a really high priority, it'll jump ahead of everything else in the cluster. But we don't have to open up every other queue to that same ability.
That also gives you the possibility to say, yeah, I've got a couple of rogue users that submit everything with 1 billion as the priority, but we still want other things to jump over that. So with the offsets, we get a little bit of a handle on these groups are always considered as higher priority. With the interaction with the admission controller that Kubernetes runs on priorities, that should give a good handle on running production loads with a higher priority than anything out of a dev or a test, because we just increase all the production loads with a number of 100. And we don't do that for any of the other non-production loads because we don't need to. So that gives you that offset, make sure that that queue has got a higher weight, so to say, a higher priority there. So that is going to end up in the design doc as the first basis, because priorities before preemption. We need the priorities to be there to go in the next step. Then the next step is preemption support. So like we already said, Kubernetes does weird things. It doesn't work for batch jobs. Even the Kubernetes people that are working on Q and for Kano and all these other schedulers and the plugins say it doesn't work for them. They have now brought up again, oh, if a job has been running for a short amount of time, it should be preemptible, but after an hour, it should not be preemptible anymore, or just the other way around. So they're coming up with all kinds of weird solutions to give weights and not preempt things and do things. Like, it still does not fit what batch jobs do. Because you can have a driver or you can have something that you really do not want to preempt. For instance, if you've got some pods which would run a notebook, you might not even want to preempt that, even if it's been running for a week or something like that, because the end user could be using it. And if the notebook goes away, all kinds of other things go bad. So what we've said is the preemption support that we've got in Kubernetes do not fit what we want. We want to add something else on top of it. But we do not want to introduce our own objects. We do not want to create something ourselves. We want to piggyback on what's already there. Because priorities are going to be there and we need them. Why not piggyback on the priority class object that we've got? So the priority class—
Which Kubernetes already does with the preemption policy.
Priority class has already got a policy as a field, but getting another field into a Kubernetes object takes about 2.5 to 3 years. That's the approximate time frame that we've seen from the CAP in the other case. So what we can do is we can put an annotation on the pod. Annotations are free, everything can use them, we can leverage them. So we've come up and said, we're going to put an annotation on the pod that says, allow this pod to be preempted or not.
On the priority class, but ultimately on the pod.
Sorry?
We actually annotate the priority class.
We annotate the priority class and we pull that information onto the pod. So if you create a priority class high with that annotation, YuniKorn will make sure that we pull that information off the priority class, put it on the pod, and we keep that in mind during the scheduling cycle, and we pass that on and then say, oh, this pod was annotated by do not preempt me. So we put it in the back of the queue, and really only if a last resort we'll do that. By the way, it is not going to be a blocker of preemption. It's going to be an advisory. So even though that you say, do not preempt me, if that is the only possibility to get a system level pod security, whether or not running, we can still overrule that. So it's advisory. It's not going to be, do not ever kill me. So that's an important little bit to keep in mind, because if we would say do not preempt me, people could start using this as, ooh, let's see, I now get a pod, nobody can get me off the cluster anymore. That's not the idea. That's not good. So it needs to be an advisory flag. So that's the way that we're gonna pull that back in.
What it will do is it'll basically bump that pod to the bottom of the list of candidates to be killed.
Although not completely the bottom, because something like a daemon set and a node or a system system.
The kubelet can still kill you for any reason if it needs resources. There's not much we can do about that.
Yeah, no, but there's also the two priorities, the Kubernetes priorities, the node and the system level high priority thing that will go above anything else.
So we have similar policy or similar queue policies that we can set as well. Again, we can fence off for preemption a subtree. And this again is really important. This kind of dovetails into the priority side of things, but it's even more important for preemption. Those system level pods, we don't want to interfere with the ability for those pods to be scheduled. Therefore, the idea would be is you run those in some sort of a system queue and you don't fence that queue. So that allows those pods to preempt anything else on the cluster of lower priority, which is what you want, because those things are things that are critical for your cluster. However, you can have individual departments or workloads themselves fenced off, which basically means when we choose victims for preemption, we only look within the current fence. And so you can say that, you know, within a particular department, I'm allowed to preempt other users' workloads within that department, but I can't preempt a workload from another department. This gives you a lot of control over it. You can ignore this entirely and just allow preemption to happen everywhere. You can supply this at every level of your queue and ensure that nobody's allowed to preempt anybody. So you can do that however you want. We're also thinking we're probably at a preemption delay parameter. There may be cases where you don't want to preempt immediately. You want to ensure that some time has passed in a pending state for a pod before you preempt, because maybe you have enough churn in your environment that you can just wait a little bit longer and allow something to terminate normally and not actually do the preemption immediately. In terms of what gets considered for preemption, now we get into resource quotas on individual queues. Currently, we support setting guaranteed and maximum resources in YuniKorn. However, for the most part, guaranteed is only really used for fairness calculations. It's not used for anything else. So one of the invariants, and we'll go over the rules of preemption in a little bit here, but essentially a lower priority task can never preempt a higher priority task. And also, no preemption will ever happen in a queue that is under its guaranteed resource utilization. So the laws of preemption, this is kind of some of you might get the Star Trek reference from way back. So a task can never preempt outside of its preemption fence. That's a one-way constraint. So again, as I talked about, this allows your preemption to be asymmetric. So you can allow things outside to reach in and preempt, but not the other way around. A task can never preempt other tasks in the same application. That might go without saying, but there's a lot of reasons why you would never want that to happen. A task cannot trigger preemption unless its own queue is under its guaranteed capacity. So if you're somewhere between your guaranteed and your max, that pod will never trigger preemption. Because the whole point of preemption is to ensure that you actually get your guaranteed resources, not that you get your maximum. So one easy way to disable preemption for a queue is just set guaranteed and max to the same value in that queue. Nothing in that queue will ever, under any circumstances, be preempted.
The fourth point, a task cannot be preempted unless it's over its guaranteed. So you guarantee some resources within the queue. If you would preempt something that's running in the queue and it would get you under your guarantee, then you all of a sudden, the next scheduling cycle would allow that queue to preempt something from somewhere else. So you get that cycle going. So you don't want that. So you stop that by putting that loop in, that thing in.
Yeah, so that's one way we block loops. Number 5 is another way we do that, which is that you can never ever preempt a task of equal or lower priority to your own.
The 6th and the 7th is, again, trying to build up that list of do not do this because we get into loops. Preemption, not below its guaranteed. Preemption policies are strong suggestions, but it's not a fixed thing. Because if we have no other solution, we'll have to take it. So it's always advisory. We can't fix that and say it is a limitation on that. Hopefully, based on these rules that we've got, that will go into the design doc, we'll get things and we'll have to work our way through. This might not be enough, but this is at least what we, during the brainstorming session and what we know has happened before in Yarn. I know there's more than enough people here that have done Yarn and preemption and written the code there and know what's going on. We do not want to get into the same kind of problems that we've seen there. And a lot of these rules are now exactly what Yarn does and the way that Yarn looks at what to preempt and what not to preempt. So we've taken the learnings, been using them, and we're adopting them to what Kubernetes allows us to do and what it doesn't allow us to do. Hopefully, this will give us at least the first decent design of preemption. We're not going to say that it's going to work 100% of the time. It's software. Bugs are everywhere. But at least, hopefully, with these rules in place, we can get up to a design and into an implementation that will get us some stability from the get-go. Yeah.
I think that's our last slide. So if we have any questions.
Okay. Any? So then it will just stay like it is. So the question was, what happens if I've got, let's say, 10 queues in a row, 9 of them are just above their guaranteed, and 1 is sitting far below its guaranteed. If I would preempt anything out of those 9 that are just above, that would get them under their guaranteed, means that they don't become a candidate. And that would leave the 10th queue sitting below its guaranteed. However, what then happens is the normal scheduling cycle comes into play. So as soon as something finishes in one of the queues, the queue that is below its guaranteed will be the first that gets assigned the scheduling opportunity. So the normal scheduling cycle will then come into play, and that should get that queue, even though that it's not preempting from other ones, it should get the first scheduling opportunity assigned.
One of the design principles is that preemption is a tool, but it's a very, very blunt instrument. And so it's probably better to err on the side of not preempting something than to preempt it if we're on those boundary cases.
Anything that we think we missed from all the Yarn people here? I think looking at what we're proposing is we're getting close to what we do in Yarn.
So one question, so is there anything which Yarn is doing? Anything else?
Anything that Yarn does that we don't want to do? Yes. We don't want to preempt within a queue. So let's say that you've got 5 users running workloads within one queue. Then say that we use preemption to move load from one user to the other user. What we say that you should be doing is create a queue per user and let it handle it as at a queue level.
And in YuniKorn, this is much easier than it sounds because we can dynamically create queues. And unlike Yarn, they don't have to have any capacity associated with them. So we can simply create a parent queue, map all of our child queues per user on a dynamic basis, and then balance them against each other with templates.
Yeah. So because what we know is if you need to start preempting within a queue, that becomes really complex. And it would be a completely different kind of preemption than that would we do between queues. So instead of implementing 2 types of preemption, we give you a solution that will give you the same behavior with only one type of preemption. That means that we can troubleshoot and make sure that that one type of preemption is rock solid instead of having two that only work half. So the less code we need to maintain, the better it is. We don't try to implement things twice. We try to implement it once, then we make sure that we can do it. And if we try to give you as many opportunities to do whatever you want. And with the dynamic queue system, we do give you that opportunity already. So that's probably that's something that we do have on the list in the design that we explicitly will call out. We do not want to preempt within a queue, and we'll give reasons for that. And some of that comes out of the Yarn world, because preemption code within Yarn is way, way, way too complex. It's not funny. And there's too many knobs to turn. So that's the other thing. We won't give you 1,000 knobs to turn. That's not going to happen. It's going to be fairly simple. You get a guaranteed, you get a max, we've got priorities. That's it. Nothing else. We're not going to give you more knobs to turn. That's already more than enough. It's already complex enough. So we're trying it to keep you as simple as possible, the minimum amount of knobs.
Nothing's not that I can think of specifically. Again, you might choose different policies depending on what environment you're running in. So, you might set relatively, if you've got a queue, you expect a burst with an autoscaler. You might set your guaranteed resources relatively low. So if something higher priority comes along, you can kill things off quickly. I don't know, every environment's different. So there definitely will be knobs that you tweak, but part of why we want to go with a very simple preemption design to start with is once you start adding like inter-queue or intra-queue preemption, the number of different policies that you need to have per queue starts going up exponentially. And it gets very difficult to reason about how the system should behave.
And also within the public cloud, often when you do have the auto scaling and things like that, preemption is not that important at that point, because normally you scale up unless you are at your limit of your auto scaling, then preemption might become important again. But then it's no different as running locally in a data center, which you've got limited resources. So I don't think there is a use case for having different preemption in the cloud compared to on-site, because preemption normally comes into play when you're out of resources in your cluster. Cloud and local data center, that behaves the same. You might even want to turn off preemption in the cloud. That could be the whole thing. But sure, if people can come up with specific use cases for having different preemption in the cloud, of course, let's implement them. But you need to come up with a use case.
Exactly.
So that's why I actually have some faith. Maybe sometimes you can relax the max, but that's a bad idea. But just some brainstorming that maybe there's some policy that is suitable for this node. Sometimes maybe it's better to kill some jobs, but sometimes it's better to buy it from something else.
Yeah. So that could be the case if and maybe we need to build that in. we haven't thought about that yet. It's not part of the design that we want to do at this point in time. That's going to be a more complex thing, and you might need to be able to have some input from almost from the side and say, hey, we know that we still got auto scaling capacity left. Do not preempt. And it's like, oh, hold on, we have run out of nodes in the autoscaler. Preempt things if I can't run. So yes, that might be something that we need to tweak. We might need to be able to put that into whatever we do. But let's first get the standard preemption up and running, and then we can always tweak and add things on top of that.
Yeah, I like the words here because I think it satisfies a lot of important use cases I can see. Because with these laws, basically we can set up our clusters based on the priority of jobs. Maybe we can mix them together. Some of the queues are running some important jobs. Also have some university queues to run lower priority ones, and then we allow cross queue preemption. So it's actually, I think it satisfies some of the important use cases.
And also with these laws, almost that we didn't come up with laws, but it was like we need to define how we're going to preempt and what kind of rules we set around this. This gives you predictability. It gives you a way to look at things like, oh, why didn't I preempt? Or why did I preempt? Because that's the other thing. We need to make this traceable and viewable from the outside. It's not good to have a black box. It's never good to have a black box. And we see that often enough already. It's not good to have that black box. So we need to make this traceable, viewable. And if we've got these rules out there, then we can say, oh, this is the rule 1, rule 2. Here's how we implement it. This is what you show. That's why we don't do it.
On the linguistic point that in the application private clouds, and so if the overall application is only about 80% of the cluster capacity, and then when we have a situation of preemption versus preempt, why? Because we can give you more extra capacity. Is that part of the
So that might be something that we need to set up there and say, if we know the size of the cluster and we're only using 60%, do not even talk about preemption because but on the other hand, oh, we're only using 60%, but hey, I'm asking for a GPU resource. I've run out of GPU resources. So I do need to preempt to get that job or that high priority thing up and running. So there's nuances there. So we might need to put something in there and say, oh, do not preempt if you're running with only 60% load or 80% load on your cluster. But if you're running out of one specific kind of resource, it might still be needed. So setting a hard and fast rule of do not preempt if you're under 80%, with all the different kind of resources and things, that might not work. So I'm always really careful about setting a kind of limit like that, say, no, don't do this. Or it might be, I need 32 gig of memory and all my machines have only 30 gig available. So I can have 1,000 nodes in the cluster. Every machine has only got 30 gig available and I need to run a really high priority pod with 32 gig. If I say, oh, I'm only using 70% of my cluster, do not preempt anything, then I'm stuck. So setting a hard and fast rule like that is really tricky. So I'm trying to stay away from that. I can understand and yes, it might be good to have. It also might be a unbelievably bad thing to have.
So in a sense, seems like this proposal is about like the local maximum, right? Versus like a global maximum.
Correct. Yes.
Right. So negotiation would be.
Could be, yep.
And to be fair, you can do some of this with a little bit of manual work. If you know, if you're in a private cloud environment, you know exactly how large your cluster is. You know, one good rule of thumb is, you know, your guarantees when added together should probably never exceed the capacity of your cluster. Otherwise, they're not truly guaranteed. And likewise, your bursts probably should be big enough to take up any slack you might have in your environment if you want to get 100% utilization. So again, you know, in the first release, that's not going to happen automatically because we don't know your use cases. We don't know exactly what thresholds you're comfortable with. But because you can specify guaranteed and max on every queue, you can probably dial in something that'll work pretty well for you.
So the gang is correct. So at this point in time, we haven't put that in there yet, but that might be something that we say, okay, going forward, if you are requesting a gang, we will not go below the gang size. But currently, no, that's not part of the design. These kind of things, that let's get this in, that we've got something, and then we can add little things like, oh, maybe guaranteed should be ending up and looking at the cluster size. Maybe we need to look at gang sizes and say, oh, you can't kill my gang then or more than this or more than that. So yes, let's get this in first. Then we've got time to do the other things. Any questions online? No? Beautiful. And let's see, we are 20 minutes over time already. So thank you all for coming today. First time in a long time. It's good to see you all around. Hopefully we'll do this again. I know that I've already got requests to do this, a meetup in an APAC time zone or a European time zone to make sure that we get at that one. So we'll have a look and we'll talk about doing something. That was one other thing that we haven't talked about. The Chinese language meetup. We don't speak Chinese. It's really difficult. It's really difficult for us to run that.
Might be obvious, but never know.
There has been a request from the Chinese language people to get that going again and make sure that we've got that sorted out. So it would be nice. We've got a number of committers, a number of PMC members that do speak Chinese. So work with us to get that properly set up again. And because there's a lot of demand and a lot of pent-up demand I can feel coming out of that area. There's a lot of little things and little bits and pieces that come out that show that people are running YuniKorn and testing it. So it would be really nice to get that going again. So, thank you. Thank you all for attending, and I think we'll call it a night for this. We'll be around here we'll stop the presentation and we'll stop the meetup. Will? Thank you.